started here. So they give you this, and this is kind of a not a very modern way of doing this type of problem where they just give you in line like the equations. Now they do give you a triangle. They're also using these Greek letters, alpha and beta. Is that something you've seen before, or what's your comfort level with using different letters?
I've seen them before. Yes, we had to use them a lot for physics last year.
Oh, you've already taken physics. That's awesome. Did you like physics?
Kind of.
Kind of. Okay. Because you said you're interested in going to a technical school. I mean, physics is that's the baseline of a lot of engineering stuff and things
Yeah.
like that. So you'll see it again though. And sometimes seeing it a second time you really you get it. You're like, all right. The reason I ask is because like it's just a comfort level with like using these letters that maybe hasn't been there before. So what I like to do is relabel what is given and then what is not given. So we're looking for A, C, and then we're actually looking for alpha. We can find alpha immediately.
We can?
Because the three angles in a triangle, what do they add up to?
180. Oh, you're right.
Yes. And you'd be kind of, well, not completely stuck, but it's good when you can find that. Now, in terms of how you present your answer, this is just a recommendation. I like to actually label the three sides, even if they're all given, and then the three angles in a table. So your third angle is always 90 degrees. And that way, there's a couple of benefits here. One, it organizes what you've been doing, but it's also easy to grade. You're not putting a lot of strain on your instructor for this. So yeah, it's your choice whether you want to do this or not. But it's a nice way to sort of close out. Okay, this is everything. You'll do that when you're all done. So to find a side, you can use sine, cosine, or tangent, among others. Do you remember anything about those from class today or recently?
Yes, I do.
Okay, so there's a lot of things to remember: sine, cosine, and tangent. I'm going to just show you how I like to remember them. You're welcome to use this convention. And the reason I like it is because it shows me the ratio is a fraction, because that's the way we're going to use it. Okay.
Okay.
So what you do is you go to one of your known angles. Now let's just say you stare at this forever and you're like, that's the only one you know. And you say, okay, relative to this angle, what is the 5? And the options are opposite, adjacent, or hypotenuse. Now the hypotenuse is always the longest side in the triangle. The
Right.
adjacent is the one that's right next to it, which could appear to be the hypotenuse, but it's not the hypotenuse. The opposite is always the one sort of across from it. So the 5 here is the opposite.
Okay.
Do you see that? The 5 is opposite the 20 degrees.
Yes.
And then you also say, well, what do I want to find? What am I interested in finding today? Well, let's find A. Well, A happens to be adjacent.
Right.
So which of these three uses the opposite and the adjacent?
The opposite in the adjacent, that would
Yes.
be tangent.
Tangent.
Right?
Yes. So that's how you decide which of these three to use. And I think there's sometimes students are unclear. Well, which one do I use and why? It's based on what angle you choose and what you either have or you want to have. All right, so we would write this. We would write the tangent of 20 degrees equals 5 divided by A. So that's on the right here is the OA part, the opposite over the adjacent.
Okay.
Okay, now the tangent of 20 degrees, it's a numerical value. Like you go to your calculator, make sure your mode is in degrees. You get a number. You get a number with a lot of decimal places. It doesn't really mean much, but that's what it is. Okay, so my question to you is, how do you get a variable out of the denominator? Do you recall how to do that?
Can you say that one more time?
How do you get a variable out of the denominator? Because this over here is a
Um,
number. It's not a variable. The variable's over here on the right.
you multiply by the variable on both sides.
That's right. That'll work there. So you're going to multiply both sides by A. The A's cancel on the right. So you have A tangent 20 equals 5. And then as I just said, I hope this is okay because we can talk about it more, but the tangent of 20 is just a numerical value.
Okay.
So you can think of it as like a number. So you divide by that number. And if you took physics, you did this at some point. You solved for the initial velocity was given, and you found the horizontal and vertical components of it, doing some stuff like this.
Oh, yeah.
You might have used sine and cosine. You can use other things here to find it. So the answer is A is 5 over tangent of 20. Do you have a TI 8384, some sort of calculator
I
available
have an
today?
80, I have an 83, but not with me. I will be right back.
Okay, yeah, go grab it.
My bad. Sorry.
Yep, no problem.
Got it. Got it. Okay. So,
Awesome. So if you're seeing my screen, I'll just briefly show you a few things here that are very important to doing.
whoa.
Yeah. So this, I think is really cool. It's just a virtual thing here. Your mode right there needs to be in degrees.
Okay.
It's really important, especially on a test, that you check every time you do a problem, whether it's in degree or radian,
Right.
because you will not believe how many times you would have it in the wrong. And the answers don't mean anything because they're, I mean, maybe they do a little bit but they're not like nice numbers. You're not checking. So you got to kind of go into it knowing, hey, I'm using the right thing. So always make sure you choose that when it's in degrees. Okay.
Got it.
So now it's the tangent of 20. You don't need the degree symbol. It already knows it's in degrees. Sorry, that did this in the wrong order. 5 divided by the tangent of 20. It's already in degrees. You don't need the degree symbol. Now there's some games you can play where you keep it in radian and use the degree symbol. I don't want you to do that. I'd like you to, because you're going to program someday as a technical person. You're
Right.
gonna want to like consider these things when you program. You're like, what is my variable? Oh, my variable's in degrees. Okay. So just make sure you get this value.
Okay. Yeah.
And if you ever have any questions about how to use this calculator, I can obviously explain it here virtually with that. So let me go back to the other screen here. And we found side A. Side A is 13.74. Now, how many decimal places to round to? Depends on what your instructor wants. If they
Right.
don't specify, ask. Don't assume that it's anything, just ask. Or wait till somebody else asks in the class if you don't want to, I suppose. All right, so here's what we've got so far. We've got the 2 legs of a right triangle. How do you find the 3rd leg of a right triangle? Or I'm sorry, the 3rd side of a right triangle?
Oh, Pythagoras.
Pythagorean theorem. Now there's also the option of using sine, cosine, and tangent. So there's 2 available options to you. Which do you think you would prefer to do?
Pythagoras, because it seems easier.
Of course, we're going to use the sine, cosine, and tangent because we want to learn how to use those. That's the whole point of this section. So
That
you
is
could,
fair.
so you can use that to check, but we're going to do it this way. So we found that A is 13.74. So we're going to use that 20 degrees again.
Okay.
And this time we want to find C. Okay, so what is C relative to the 20 degrees? Is it the O, the A, or the hypotenuse?
The hypotenuse.
It's the hypotenuse. Now you have to pick the other side. Now you could use the 13.74. I recommend always using the given sides. So we're going to use the opposite.
Okay.
So which of these 3 uses the opposite and the hypotenuse?
Cosine. No, sine.
Sine. Okay, and the sooner you remember like opposite over hypotenuse, adjacent over hypotenuse, tangents opposite over adjacent, the sooner you learn all that, the better. It will help you beyond this. So we write the sine of 20 degrees equals the opposite over the hypotenuse. So the opposite is 5. It's always a fraction over C. So
Okay.
just like in the last problem, you have to get the variable out of the denominator.
Okay.
So to do that, you multiply both sides by c.
Right. And then you divide by sine of 20 on both sides.
That's right. And this time you're going to go to your calculator and you're going to tell me the result after you substitute this in. I will obviously check here.
14.62.
That sounds right. Yes, 14.62. Very good. Now let's just do it for one problem. Let's just do the Pythagorean theorem to show that it actually is the correct answer. So you mentioned it's a squared plus b squared equals c squared. And we were given, we'll just go 13.7 for a, b was 5, and this is c squared. Now I want to show you this on here. You take the square root of both sides to get c. Okay. Now I want to show you how to do this in the calculator, but I'm gonna write it out first. So it's the square root parentheses. So what that does is it puts a parentheses right there. It's like saying that's inside parentheses. 13.74 squared or caret 2 plus 5 caret 2, and then you have to close the parentheses there. So this calculator we're looking at. Let me go back to it. It does not get enough respect. This calculator has more computing power than the first spaceship that went to the moon.
Yeah.
It really does. And when I say that, what I mean is like it can do more calculations per second. It's got more memory and storage, all this stuff. You know, like compared to your phone, I mean, it looks like a phone booth or something. It's very archaic. But like, do you drive?
No.
You don't drive yet. Okay, that's a bad example. Well, imagine you wanted to drive somewhere and you push the car instead of getting in it and driving. And there's somebody like you're like, oh, we're just going to push our car today, right? You would never do that, right?
Right.
So don't be the student that does this. This is the wrong way to use the calculator. And I'll help you over time here. Don't do that. And don't do, okay, plus 5 squared and then square root. Like this works, but this is not an efficient way to do it. Okay.
Right.
The correct way to do it is to tell the calculator to do everything at one time.
Right. That would make sense.
And this takes a little bit of time to get used to, but it's in the long run, you're doing it, and you're going to see this is the correct answer. It's the same thing. In the long run, there's some extreme benefits to this. Now you're going to take some technical classes in college. There's some things there that you really will come in handy if you follow this approach that we'll get to someday. But the idea is like the calculator is a computer. Let it do the work. Let it do all the hard work for you. Okay, so your C is 14.62, which is exactly what you told me using the other approach.
Right.
So see how these are the same, and they should be. They
Right,
should be
they
the
should be.
same. So the point here is though is you can use either Pythagorean theorem or the sine cosine tangent, but they should give you the same answer. If you had the time on a test, you would do them both ways. You don't need to though, but you could.
Right. Okay.
Okay, so we spent a lot of time on that problem. The next ones are going to go much faster. But any questions that I can answer on that to start?
No, thank you.
Okay. All right, let's go 29. All right, so they give you some information again. I'm going to snip in the triangle. We're going to use their triangle for this problem. All right, so we label what's given. So C is 9, beta is 20. We want to find little a, little b, and little alpha. So what is the value of little alpha or little a here?
70 as well.
70, yeah. So you can, what I would do is label it off to the side, and then I wouldn't keep using the letters because they get sort of too much. All right, now, this is more akin to that like physics problem where they give you the initial velocity and they want the horizontal and the vertical components.
Mhm.
So we'll see that here when we do this. So when you look at the 20, let's say you want to find A first. And you have the 9. A is the adjacent, 9 is the hypotenuse.
Right.
So of the 3 trig functions that you know, sine, cosine, and tangent, which one uses the adjacent and the hypotenuse?
Cosine.
Cosine. So it's the cosine of that angle, the cosine of 20 degrees equals A over 9. So this time the variable's in the top, but it's more to do with what's given and what's not given. I guess those both look kind of the same. Okay, so now you need to solve for A. Solve for A. How do you do that?
You multiply by 9 on both sides.
That's right. The 9s cancel. Like you to go to your calculator and compute this value for us.
Okay, hold on. 1 second. Cosine 20. Oh wait, hold on. 9 cosine 20. 8.46.
Yeah, 8.46. Good.
Awesome. And then we gotta do the same with
Yeah, so I want you to find B, and I'll give you the option. Either use the sine, cosine, or tangent, or you can use Pythagorean theorem. Whichever one you want.
I'm gonna use sine cosine tangent.
Okay.
Okay. So to find B, we need the opposite and the hypotenuse, right?
Yes.
So it'd be sine of 20 equals opposite B over 9.
Very good.
We multiply by 9 on both sides. And B equals 9 sine 20. 3.08.
So you got B as 3.08.
Yes.
Okay, let me just double check that. Yep, I agree. So not too difficult.
Right.
You just got to know which to use, sine, cosine, or tangent. And
Right.
that's the key here. That's completely the key to this.
Okay.
Okay. Now there's a bit more here to it that let's get through at least one more problem here before I go off into the deep end of what we're doing here. This is well, it's sort of a story problem. They're just giving you the information in words here. Okay. All right, so here we go. It says the hypotenuse of a right triangle is 5 inches. If one leg is 2 inches, find the degree measure of each angle. All right, so the first thing is to actually draw a right triangle. I generally draw mine with the vertex that's 90 degrees down on the lower left. Like
Okay.
this. That's kind of the orientation that looks correct to me. You may not agree with that, and that's fine. Like, I'm not right on this. It's just a preference I
I'm
have.
not right.
Yeah. There's some bad triangle jokes on the internet if you really want to get unlimited time to look out there. But they're saying the hypotenuse is 5 and one leg is 2 inches. So they're both legs. So you have a choice here. You can either say, well, this vertical one is 2 or this horizontal one is 2. That may lead you to wanting to draw one that's a little more or representative of it. Like that's a little more representative, but you could
Right.
also draw something like this,
Right.
and it doesn't matter. The answer does not change in how you draw it. It's just, you have to decide what you like. Which of these, well, of these two on the right, we'll call them A and B, which is more what you're thinking of when you look at this problem.
B.
B. Okay, so we'll go with B. So I'm going to just draw it a little bit bigger just because I've got my screen here. So this is 2, this is 5, and we're going to call this little b.
Okay.
Okay, now how do you find the third side in a triangle when you're given 2 of the other sides?
Pythagoras.
Yes. So we have a squared plus b squared equals c squared. Your a is 2, your b is unknown, your c is 5. So b
Okay.
squared equals 21, b equals the square root of 21. So as a math student here, you do want to show that it is the square root of 21, but I would approximate it. Let's go to 4 decimal places with that, please. If you could calculate that for us.
Right. The square root of 21.
Yes.
4.5826.
Yep. 4.5826. Okay. So let's go ahead and label that in here. So this is different than the other problems that we did, because in the previous 2 problems, one of the angles was given.
Right.
But this one, the angles are not given.
Right.
Okay, so I'm gonna call this alpha for the moment, and we're gonna find alpha.
Okay. So it would be like you could do either the opposite and the hypotenuse to
Okay.
find alpha.
You could also use the adjacent and the hypotenuse, and you could even use the opposite and the adjacent. So we're actually do it all 3 ways, so you can see that they do all give you the same result. So let's start with sine. Sine alpha equals 2 over 4.5826.
Wait. Isn't sine opposite over a hypotenuse?
It is. Sorry about that. A mental lapse there.
Mm.
Yeah, sine alpha is opposite of hypotenuse, 2/5. From class, do you remember how to undo sine?
Inverse sine, right?
Yeah, sine inverse. Now, you do not need to show this, but I just want to write it out one time so you can see it. This is like the correct way to write it, but you can just go right down here and say, okay, alpha is the sine inverse of 2/5.
Right.
Okay, now on your calculator, that's the second sign. So you hit the second button first and then sign. Will you try that for us and tell me what you come up with?
23.57.
Yeah, so let's
81 something.
let's go 58 on that rounding. Okay. Now let's use cosine. Cosine of alpha is 4.5826 adjacent over hypotenuse.
Okay.
So now you're going to undo cosine with cosine inverse. So in your calculator, again, I want you to try this. I won't make you do this on more than just this one example, but it's good to see it, to believe it. You should get 23.58 or be so close that it essentially is.
23.577. So 5.
So
8,
5.8, yeah. So that confirms it. And now we can do it with tangent. Tangent alpha. Hang on just a second here. Tangent alpha is, we go back, that was the one I was starting off with, leading off with. It's the 2 over the 4.5826. And you you will see that it too, where it also is 23.58.
Yeah. Yeah.
Okay, so now if we go back to our drawing here, we just found that alpha is 23.58 degrees. To find beta, we could use sine, cosine, and tangent, but we can also say to ourselves, well, three angles in a triangle add up to 180. I already know that this is 90. So beta here is really 90 minus alpha. The two non-right
Yeah.
angles have to add up to 90. So
Right.
beta is 90 minus your answer, 23.578. And you should get, what do you get there? 66.422 or
Um,
42 degrees, 42 degrees, something like that.
so yeah, 4-2.
Okay, so that is everything for this problem, and allows me to give you some options for how to proceed from here.
I kind of thought this would take longer.
That's okay. There's lots more to say here. Now, do you have anything else you want us to work on tonight? Any other problem sets or anything? Otherwise, I'll just talk more about this topic with some more useful information.
Um, actually, the number 13, I was doing it at school, but it didn't seem right.
Okay.
Cosine 10 degrees over sine 80 degrees.
So
Why?
it says do not use a calculator, right? So you
Right.
immediately go for the calculator and you
Well, no, I was wondering how I did it without the calculator. And I spent like 30 minutes with a friend trying to figure out how to do it without a calculator. Then I pulled out a calculator and it's one. And I'm like, that doesn't make sense. Why is it one?
Yeah, so let me do a couple of things here. The first is I'm going to send over this it's called a cheat sheet, which I don't like. It's a reference sheet for this class that I really like. Actually, let me make sure I'm grabbing the right one. They've switched which one it is. The search engine. Okay, so it's that one. Okay, so here I might have said this to you before, but in this this reference sheet here, there are. Oh, did he update this? Sorry, I'm just talking to myself because this thing hasn't been updated in like 15 years.
Awesome.
So let me get you to the part that you care about. There's a lot here. It's kind of like physics. It's overwhelming. So there's these things called cofunctions.
Right.
And that's how to do this problem. It's like to realize that this is a cofunction. So the way the cofunctions work is that sine goes with cosine, cosecant goes with secant, and tangent goes with cotangent. And the idea is actually that all of those are graphs that are phase shifted 90 degrees. So here's how you use this. Cosine of 10, if we use this one in the top, sorry, this first one here, cosine 10, this is the right side for cosine, is
Mhm.
sine 90 minus 10, which is the sine of 80.
Okay.
So instead of cosine 10, it's sine 80 over sine 80, which is 1. Now, let's say you didn't like that. You're like, all right, that's magic, or that's garbage. You could look at sine 80. So in your cofunction for sine, let me just snip that one in. Your cofunction for sine is that do it like this. Your theta is 80. So cosine is 90 minus your angle, which is 80.
Okay.
Which is cosine of 10. So instead of sine 80, it's cosine of 10. So it's cosine 10 over cosine 10, which is also 1.
I see.
So that like this is not very helpful. Maybe the way I've done it, the way to really introduce this is to say, you already know this, that sine of 45 degrees is the cosine of 45 degrees.
Right.
And if you look on your unit circle, the sine of 30 is the cosine of 60.
Right.
And you should verify, like if you don't remember this or this isn't clear, you can go look. The sine of 60 is the cosine of 30. And
Right.
you'll eventually sit there and be like, huh, they all add up to 90. Right? So if I say, well, it's the sine of x, what's the cosine of 90 minus x? Because x plus 90 minus x has to add up to 90. So back long time ago in math, you were coming up with rules. It's like, well, does this work? When x is 60, is 90 minus 60, 30? Yeah. When x is 45, is it 90 minus 45? It's 45. So that's kind of a proof here. But what you need to remember is that like whatever the value is on the left, the one on the right also adds up to, they have to add up to 290. So let's say I said it's the sine of 22 degrees. This equals the cosine of what number? What has to go here so that they add up to 90?
78.
68.
68.
Now go to your calculator
80.
and make sure it's in degrees and just type each of these in. And you should see that they're the same.
Sine 22. Okay. And cosine 68. They are exactly the same.
Right. So let's say I asked you for the sine of 22 divided by the cosine of 68. You can substitute in, you can say, all right, well, the sine of 22 is really the cosine of 68 over the cosine of 68. They're the same on the top. So it becomes 1.
I see. They are yeah, okay.
So this works for more than sine and cosine. So sine and cosine are paired, but so are cosecant and secant. So it's the same idea. I was like, all right, it's the cosecant of 49 degrees equals the secant of 41 degrees, because 49 plus 41 equals 90.
Right. Okay.
If I asked you, and then reverse, I said, oh, that's the secant of 82 degrees. That's equal to the cosecant of what number goes in here so that they add up to 90?
8 degrees.
8 degrees. And the last one is that tangent goes with cotangent. So it's the same deal. I could say, all right, it's the tangent of 15 degrees equals the cotangent of
the equals the cotangent of 75. Yes, no. Yeah, 75.
Yep. Yes. So you just got to be able to add or subtract, right? But that's the basis of these problems. So I mean,
Right.
I apologize that you had to spend so much time doing them. But we should look at a problem like 12 now to see how that could be like another potential problem that you might see.
All right.
So yeah, you could go to a calculator, but it would say no calculator.
Use.
No calculator. So just like we said here, oh, tangent goes with cotangent. Okay, so
Right.
that means that tangent of 12 is really the cotangent of 78.
Right.
And you don't need to know what they are. You just need to know that they're the same.
Right. Okay.
It's like,
And since they're both the same, it equals 0.
yes.
Got you.
Like if I asked you what x minus x is, you just tell me it's 0.
Right.
You don't know, you don't care what x is. You just like, well, they're the same.
Right. So because I know they're the same,
Right.
okay.
So like a similar problem would be sine of 32 plus 8/9 minus cosine of, I gotta be careful here so I get this right. Sorry here, 57 plus 1/9. Okay. And I'm choosing something that's ridiculous here just to emphasize this point.
Oh, okay.
The sine here is the same as the cosine of 57 plus 1/9 minus the cosine of 57 plus 1/9. They're the same, so it's 0.
I see.
They sometimes do this symbolically as well, but I'll hold off on that unless you feel like there'll be a question on that.
Nope. I think it's okay.
All right, so I'd really like to get to some other sine, cosine, tangent stuff, but if you have more questions, we have time. You're the customer. You get to dictate what we do next. What do you want to do here?
Whatever you think is best.
Okay. All right, so this is one of my favorite triangles. It's a 3, 4, 5 triangle. And I'm going to use A for that angle right there. And I want us to write out the sine of A, the cosine of A, and the tangent of A. So can you help me out with those, please? Sine, cosine, and tangent. What goes on the right-hand side?
For sine of A, it would be 4/5.
Okay. How about
Cosine would be 3/5.
okay, tangent?
4/3.
Okay. Now I'm going to label this angle B, and I want you to tell me the sine of B, the cosine of B, and the tangent of B.
The sine of B would be 3/5.
Okay. Cosine of B.
The cosine would be 4/5, and then the tangent would be 3/4.
So I want to direct your attention to the following here. What do you notice about these right here?
They're the same.
They're the same. Does that surprise you, given that whatever angle A is, B is 90 minus it?
Yeah, kind of.
Still a little surprised, because that's what we just did. That's this whole discussion that we've been having is like whatever the sine is, the cosine is 90 minus that. Let's
Okay.
keep going here. What do you notice about these?
They are also the same.
Yes. So the idea is like this, and this is how they build these identities, is whatever A is, B is 90 minus A. So the sine of A, which you just told me is 4/5, equals the cosine of B, but the cosine of B is really 90 minus A, which is also 4/5. So that's why these are the same.
Okay.
Anyway, you could just so that there's a lot of things that kind of like overlap in this part of the course. You have multiple paths to get to the same solution. Okay, so another like little thing I want to emphasize here that maybe isn't made clear. The sine of A is a ratio of sides. Same with the cosine of A, tangent of A, they're always the ratio of sides. Like that is the meaning of sine A.
Hmm.
And where this gets confusing, I think, is that A is an angle, but the sine of A is a ratio of sides. The cosine of A is also a ratio of sides, but A is an angle.
But A is an angle.
Yes, like A is an angle, but the sine of A is the ratio of sides.
Huh.
Let that kind
Why
of
is
sink in. It's a little bit odd, right?
Yeah, just a bit.
So let's look at something that you know here. The sine of 30 degrees is 1/2. Let's draw a triangle here. This is 30 degrees. It's 1/2.
Okay.
The third side of the triangle is from the Pythagorean theorem. It's from, we'll call this A for the moment, A squared plus 1 squared equals 2 squared. A squared plus 1 equals 4. A squared equals 3. A equals the square root of 3.
Hmm. Okay.
All right, so just hang on with me here. What is the cosine of 60 degrees?
Uh, the cosine would be √3/2, right? No, 1/2.
It's 1/2. Ah, interesting. Notice it's the ratio of sides, right? These are
Yes.
ratios of sides. It's also the same as 90 minus 30. See how these are the same again?
Yes.
Because they're cofunctions.
Hmm.
So we'll do this again here. Let's go with the sine of 60 degrees. What is the sine of 60 degrees?
The sine of 60 degrees is √3/2.
√3/2. Very good. So the cosine of 30 degrees should also be √3/2.
Right.
Is that the case? Is the cosine of 30 degrees √3/2?
Yes.
It is. So notice these again are the same. So the angle is, what I'm trying to get you to see is the angle is different than the sine of the angle or the cosine of the angle.
Hmm.
But if you're looking at the sine and the cosine, there is a relationship between the numbers.
Right.
So maybe that will be clear as well. Okay, let's do a couple of story problems with the time we have to close out here. If that's okay with you.
Yeah, no, that works.
Oh, do you know your final schedule? Do you know when your finals are for both of your classes? Have you looked
For
into that?
both.
Yeah, your math and then your econ.
Oh, econ, we're having a test Wednesday and Thursday, and then we're having our final in like 2 weeks.
Okay.
And then math, I think it's either this week Thursday or next week Thursday.
Okay. Great. Just always keep those dates in mind. That way you're not surprised the day of when you have the test.
Right.
All right, so let's look at a problem here. It says finding the distance across a pond. It says find the distance from A to C across the pond illustrated in the figure. There's one important thing that they have not done here. This is a right triangle. You need to know that to be able to answer this question.
Okay.
All right, so one of the things I like to do sometimes is draw the triangle without the picture, just because there's so much going on here. We got 100 and that's 40. Okay. And we want to find the distance across the pond. I'll call that little b. Little b is generally across from big B, like that.
Hmm.
You might think it's AB, but it does say A to C in the problem.
Right.
You know,
So that
don't,
would mean we have to find little b, right?
yeah, little b. So what you always want to do is relative to that given angle, you've got to figure out what the two things that are given or you're trying to find are. They opposite, adjacent, or hypotenuse.
Hmm. They
So
are
what do you say here?
opposite,
B is opposite. And how about the 100?
adjacent.
It's okay to label them. You will not do it forever. You'll eventually say, oh, I got it. Which of the three trig functions uses the opposite and the adjacent?
Tangent?
Tangent. So the tangent of 40 degrees equals b over 100.
Hmm. Okay. And so you multiply by 100 on both sides.
That's right. And then you go to your calculator with its capabilities and you see what you come up with.
83.91.
You are, so that sounds pretty reasonable. You said 83.91.
Yes.
You do need a unit of measure, just like in physics. This is probably the
So,
most comparable to physics, anything that you've
right.
done. So make sure you label your answers. Just like we mentioned earlier, like make sure you're actually solving for the right side. It's maybe you did this in physics where you solve for things that you don't actually need or they're intermediate results. Like make sure you know that you're actually like what you're actually solving for.
Right. Physics was weird. We had to solve for like 3 parts of 2 different triangles. And then just to figure out that the triangles didn't matter, we had to find the force of a cube hanging from the triangle.
Yeah, there's a lot in physics, lots of things going on there. So, all right, well, if you need a lesson before your for your tests, but you know, your mom knows how to schedule or you know how to schedule, but that is it for us for today. Send you the notes here shortly and I'll see you next week.
Awesome. Thank you so much.
You're welcome. Bye now.
Have a great week.